This video describes advanced features available in the Sbt products. The more significant ones discussed here are ASE 2000 remote connectivity, reporting communication indication and statistics, redundant line configuration, the calculation package, Spt Explorer Windows utility, and NERC security concerns. ASE 2000 version 2, release 2.17, and any subsequent release has the ability to issue a remote connection to a Sbt unit for monitoring mode operations only. No commands can be issued. The Spt will return over this connection communication data for one communication path, either a serial channel or network connection. Establishment of the connection requires two steps, one in the Sbt editor and the second in the ASE 2000. Step 1 is to tell the Sbt which port is to be monitored. Before we go on to this step, let's look at the sample configuration we're working with. This configuration has three communication paths going to DNP devices, one on serial port 1, one on serial port 2, and a network connection. And the Sbt is converting all that data to an IEC 104 device on network port 2404. To tell the Sbt which one of these communication ports is to be monitored, we select Sbt and Remote Monitor, fill in the remote port, which is default to 3000. This is the port the ASE 2000 will connect to get remote monitor data. And then we need to select one of the communication paths. So we select direction, which is from master to RTU. I'm going to select to RTU. Then the Sbt communicates with the Sbt hardware and uploads the configuration. Notice that only protocol DNP is on the 2RTU side. I can select my line, which is line 1, 2, or 20,000. 20,000 being the network port. That's what I'm going to select. And monitor. We're all finished. The Sbt will now accept a remote monitoring connection, and data will be returned over that connection for DNP network port 20,000. The last step involves the ASE 2000 version 2. Start the program and do four simple things. At the bottom, you will see four icons showing your activity. The rightmost one is Remote Monitor, which is the mode that communicates to the Sbt in the way we just described. Second, enter the IP address of the Sbt box, which is, in this case, is 192.168.1.155, and enter the port number, which we set up in the Sbt editor as port 3000. Go to File, select Protocol, and select the protocol we're monitoring, which in this case is DNP LAN WAN, and start. The test set makes a connection to the Sbt, and the communication messages as they appear are sent up to the test set just as if the test set were physically there at the Sbt box. When configuring the Spt database, the editor allows creation of indication and statistic points at the 2RTU device. The Spt SRV supports a variety of each type of point. Indication points report true-false information about various operational statuses of the remote device, such as communication error. Statistic points provide numerical information, such as number of messages sent. Indication points can be linked to the digital input points at from master devices. Statistic points can be linked to analog input points. In both cases, they are reported as normal input points, except that the quality codes for these points are always good. For example, to add an internal indication point, we right-click on the device, say Add Object, Internal Indications, right-click Internal Indications, add a point. I am going to select COM failure. I'm going to take this point and drop it over the binary input points in the upstream DNP device, and we can see we're linked. So binary input point number 8 reported to the DNP device will contain the COM fail status of this Modbus device. 1 will indicate that the device is in failure, and 0 will indicate that it's normal. The same procedure can be followed for a statistic point. Right-click on the device, Add Object, Internal Statistics. Right-click on the statistics and add a point. I'm going to select Messages Sent. Take this point and drop it over the analog input points on the upstream device. And we see that analog input 8 reported to the DNP device will contain the number of messages sent to this Modbus device. The total list of internal indication points supported for all protocols are COM failure, set when all points at the remote site are out of date; sensor failure, set when at least one point at the remote site is out of date; restart, the device has reported a restart condition from a power failure; control failure, the last control output command issued by the SPT to that device has failed. And the next 3 are used for redundant line configurations, in case you have 2 communication paths going to a single RTU. Line A failed, indicate that the first of the 2 lines has failed. Line B failed indicates the second of the 2 lines has failed. And line status includes which of the 2 lines is currently being used for active communication. 0 for the first line and 1 for the second. The complete list of supported internal statistic points include bytes sent, bytes received, messages sent, messages received, message errors, which are total number of messages received that contain errors such as CRC or parity, and timeouts, messages sent for which a response was expected but not received. The next feature to be discussed supported by the Spt SRV is redundant line communications. Redundant lines are supported both in the from master and to RTU direction and are simple to configure. In this case, for DNP, we right-click on the protocol and say Add Redundant Lines. And under the resulting redundant line node, we can add serial line 1, serial line 2, and a device. From that point on, we configure the device just like we configured the device in a non-redundant situation. Same thing for 2RTU side. Add redundant lines. Add 2 lines here. And add a device. Multiple communication paths can be used for communicating to an RTU device. Both can be network connections, serial, or a mixture. One line is the primary and the other is the backup. This can be defined statically in case there's an advantage of one line over the other, or the Spt can decide in case the use is arbitrary. This configuration is set by properties on the redundant line nodes. This property, primary line, of course, says which of the two lines is the primary one, the first or the second in the list. And the switching here is how to decide which line to use. The default COMFAIL says we will continue to use the primary line unless there's a communication failure. And this property up here says how many failures we have to detect before we switched. So if we use the COMFAIL logic and there's 5 failures, we'll try to switch to the backup line. We'll keep trying the primary line by sending heartbeat requests out, and if the primary line ever comes back online, we'll switch back to that. The other option is round robin, in which case the Spt may alternate between the two lines as the primary lines, depending on which one it thinks is the best to use. The next feature to discuss is a calculation package embedded within the Spt software. To discuss this, we have a database with 8 real analog input points, points 0 through 7, and an 8th point, index 8, that I created to hold the calculation. To enter a calculation on this point, we right-click and say Calculation, which will call up the calculation package. The calculation editor appears as shown. All the points available for calculation source, which are all of those defined with a point name, are shown here on the right. There's our 7 real points and our calculation point. And all the options you can use to create a formula are here. I'm going to create a simple one. For example, if point AI0 is greater than point AI1, then I'm going to use point AI0, else I'm going to use point AI1. So there's the formula. Now if I want to test this formula to see if it's accurate, I can hit the test button here. The test calculation will use these values for all the points and show you what the result is. So if I want to test the value of AI0 being 1, I can enter that here and try to test again, and now we will see all the steps done by the calculation editor and what the result is. If this is OK, I select OK. And I can see for my calculation point AI8 that the formula has been saved to the database. Now when the Spt runs, the value of AI8 will be calculated continuously from this formula. The next utility supplied by ASE is a Windows-based web browser called Spt Explorer. To use the Spt Explorer, simply run it and enter the IP address of the Spt that you wish to examine and press the browse button. The Spt Explorer will communicate to the Spt TSRV, upload the database, which you can see here. We have one DNP line and one Modbus line. To look at information about any node here, just click on the node. For example, clicking on the Modbus RTU node shows all the points, our 8 input coils, our 8 holding registers, the current value, and the current quality, whether it's good or not. Clicking on the line will show you the total number of messages and bytes sent and received, error conditions, if any, whether the line is enabled, and the current quality, which is good. An alternate statistics page is available by right-clicking on the line and selecting a communication summary. The communication summary lists total polls, errors, timeouts, response time of the last message in milliseconds, so this is 26 milliseconds, the average response time from all the polls so far, and the minimum and maximum response times. This information can be saved to an Excel file for examination by doing File and Capture File, which will write it to this CSV file you can read from Excel. And if there are more RTUs on the same line, they will appear in rows following the row underneath the first RTU. The last issue involves securing the Sbt unit for some NERC SIP concerns. NERC's main concern is with network access to critical devices. Initially, the Spt TSRV units allow configuration access over a network connection or through a serial port in the front of the unit. The serial port requires physical access to the device, so is typically not a NERC concern. The network connection is. When access is allowed through the network or serial connection, the Spt TSRV is said to be in unsecure mode. When the network connection is disabled, the unit is in secure mode. In this mode, the only network access allowed, if any, is that required for SCADA communications, such as over DNP3 LAN WAN. Secure mode is set from the editor as shown. While no FTP, Telnet, or connections from the configuration editor are allowed in secure mode, view-only ports accessible by Spt Explorer or the ASE 2000 monitoring remains active. Once set, secure mode can be disabled in two ways. 1. Connect a serial cable between a PC running the Sbt editor and the diagnostic serial port. Use the unsecure command shown in the list to the left. Or 2. Cycle Sbt power. Unsecure is allowed over an IP connection for the first 10 seconds after power up.